Hey, this is Scott. Welcome back. So, this is going to be a short video. It's going to be SAS IML to R conversion, specifically to kind of some matrix algebra, some stuff that's applied to multivariate statistical analysis. But yeah, I'd love to hear from you. If there's value in this, I can do some more of these, um, either in R, the conversion thing, or whatever. But I was a big SAS IML fan for years and years and years, and R has really kind of taken over in a lot of ways. So, and both are great for matrix algebra, linear algebra stuff. So let's look at the comparison. All right, so if I look at line one, here's how you comment out in SAS IML versus R. It's a simple hash sign. And then, of course, when I used to program in IML, I'd do the line size or spacing 80, and then proc IML to tell SAS what to do. And then to load a matrix, what you do in IML is you would type in really kind of what the matrix looked like. Right here, I'm defining A. R is a little bit different, and you can see row 24 here where I am, and use the matrix function. And then what I can do is I input the vector, really, a column vector, and then I tell it to apply the matrix function with 2 rows and do it by row. So let's do that real quick. So if I do that, you can see that that is input. And then the next thing that I would do in IML is I would use the eigenval and eigenvec, 2 different functions for that matrix A, right? So 2 different functions. In R, there is just one function, eigen. So I'm going to label this eigen underscore A, and I'll execute that. And then if I see the values, I just put the $ values, and there they are. You can see in the lower console down here, that's 2 and -3. And then if I execute the vectors themselves, you can see the eigenvectors as well. Okay, so then again, these are just simple print statements up here at the top, which you'd use in IML to print that out. And then I would say strip the normalized eigenvectors in IML, and of course you just use the hashtag. And then what I'm going to do is I'm going to create this lambda 1 for the eigenvalues, lambda 1 and lambda 2 for the formula for spectral decomposition, and then the eigenvec itself. To strip those normalized eigenvectors out. So in R, I'm just going to pull this. I'm just going to pull this out, and the individual values out, and then the columns out here. So here, to execute those statements. And then if I wanted to see them, I could actually see what each one looks like there. Okay, and then to do this, the spectral decomposition function is just lambda 1 times, and I missed this in IML, right? So it's just times the vector and the transpose of the vector, and then again the vector and the transpose of the vector, the lambda, and you can bring these on out. But you have to add something in R. The way I was doing it was with this matrix function, which essentially does that transpose of that vector. And if I do that, and then calculate the spectral decomposition, and that's it. So I'd love to hear back from you. Thanks for joining, and I'll see you next time.